Okay, today we're going to be talking about writing a parallel equation that goes through a specific point. Okay, so by now you guys should already know that parallel lines have the same slope, right? So if I want a parallel line or equation that's parallel to this equation here, the parallel equation is going to have that same slope, right? So I know that it's going to be at least this much, 1 over 3x, okay, because the slope has to be the same. What I don't know of this line is what specific y-intercept it's going to have, because it has to be that line that goes through this point. So, like, for an example, if I were to just kind of draw this out, I'll come over here to this space. Okay, basically what it's asking is it's got a line that's doing something like this, and it wants the parallel equation that goes through, like, this point right here, or something like that. It's not exactly that point because it's down here and there's not much room. But basically, it's going to want that specific line that goes through that point that is also parallel to the original line. So it's going to have a specific y-intercept, okay? So what we're going to actually have to do is we're going to have to solve for that y-intercept. So I know the beginning part. What I don't know is the y-intercept. So again, thinking back to the equation for a line, y equals mx plus b, we usually use b as our variable for our y-intercept. Honestly, you can use whatever you want there, just as long as you know that it represents the y-intercept. Okay? Now, because I know that this parallel line is going to go through this point at some point, I know that at some point on this line that both the x and y are going to equal -5 and then -1, because that's my x-coordinate and that's my y-coordinate. So I know at some point this equation, the x and y, are going to represent these two numbers. So what I can do, because I can't solve it until I get it down to one variable, what I can do is plug these in for the x and y, and then that will leave just the b left that I will have to solve for. So let's plug them in. So -5 would go right here with the x, and -1 would go with the y, so it would be -1 is equal to 1 over 3 times -5, and then plus b. Okay? Now, this is a fraction times a number, which you guys all freak out about, but again, your calculators do this for you. Mine have the little fraction button right there. Nebeker's, let's see, she has a fraction button right there, so the ABC. Okay, so both these calculators have a fraction button that you can use to do this, so you don't actually have to worry about figuring out how these multiply or anything like that, even though it's not that hard. Okay, but to use the fraction button, you just do 1, fraction button 3, and then times it by -5. That gives you -5 over 3. Okay, so we get -1 is equal to -5 over 3, and then plus b. Then we need to solve for b, so we need to, this is a negative, so to move it to the other side, we would have to add 5 over 3 to each side. So again, your calculator does this for you. So -1 plus 5 over 3 is going to be 2 over 3. So the final answer, B, is going to be 2 over 3. So I'm not quite done. Now that I know what the y-intercept is, I'm going to come back up to my original equation and plug it in. So my final answer is going to be y equals 1 over 3x plus 2 over 3. Okay, that's your final answer. Hooray for bells. Okay, next one. Let's do one where we have to solve. So let's look at this problem right here. So on this one, we can't see our slope on the original equation. In order to see the slope, it has to be in the slope-intercept form, which means the y has to be all by itself on one side. So we have to move everything away from the y. Now, this is basically just a two-step, a party problem, right? The x term, whether it's like a number times x or whatever, is like your acquaintance because it's adding to your host here. Your host is your y. And then the number multiplying with the y would be your best friend. So you just treat it like a party problem. Acquaintance is going to leave first, then you get rid of your best friend. So this is a negative x, so we would add x to each side. Add x, cancels out there, leaving just 2y is equal to, and I'm going to move the x in front so it stays in the form you guys are familiar with. So it would be just x and then minus 20, because it's a negative 20. Okay, and then the last step is to get rid of this best friend. So when we divide, and there's more than one term on the other side, you got to remember that it goes to every term. Okay, it's going to go to every term there. So it cancels out there, and you're left with y is equal to x over 2 is the same as 1 over 2, so 1 over 2x, and then minus 10 over here, but again, that doesn't really matter. All we care about is the slope. So the slope of my original equation is going to be 1 over 2x. Okay? So then to set up my equation, again, I set up what I know. So I know the slope is going to be 1 over 2x. What I don't know is the y-intercept. That's what I need to solve for. So I'm going to plug in my coordinates. So the first coordinate's your x-coordinate, second coordinate's your y-coordinate. So that's going to go where the x is, that's going to go where the y is. So I get negative 5 is equal to 1 over 2x, or sorry, that became 5, and then plus b. Okay? Then I just multiply 1/2 times 5 is going to be 2.5. So I get negative 5 is equal to 2.5 plus b. Then I just subtract 2.5 to each side. Cancels out there. Negative 5 minus 2.5 is going to be negative 7.5. So again, last step is I'm going to come back up here to where I set it up, and I'm going to replace the b with what I now know what it's equal to. So y is going to equal 1 over 2x minus 7.5. And that's all you're doing for the parallel equations through a point.